Hello, welcome to Transformations Day 2. This is going to be pretty brief. We're going to talk about how to graph inequalities. So let's go ahead and get started. First example, we're going to graph the following inequality. We're going to use transformations, now that we know how to do that, to help us graph the boundary line, and then we'll do some shading. So on this one, y is greater than the quantity x plus 3 squared minus 4. So what are the transformations? What's going to happen to the parent function of the quadratic? Well, if it's x plus 3, then it's x minus negative 3. So that means that we will graph, the graph will shift 3 units to the left. So let's write that down, 3 to the left. It also is going to shift down 4 units. And so we have what we need really to graph this. If you want to go ahead and graph the parent function and then do the shift, we can. What's going to happen on this one is the vertex actually from 0, 0 shifts left 3 units and down 4. So 1, 2, 3, 1, 2, 3, 4, which is right here. So there's your new vertex. The shape of the graph didn't change, so we can actually just go ahead and graph the parent function from the vertex. So I'm just going to pretend this is the origin and go 1 up, 1 over. If I square 2, I get 4. If I square 3, I get 9. Now I know that's not 9, but what I'm talking about is I'm going 3 units from the vertex and 9 units up, and then we can do the symmetric on the other side. 1 to the left and 1 up, 2 to the left and 4 up, that's like 2 squared, and then 3 to the left and 9 up, and that's like 3 squared. So there's our parent function shifted 3 units to the left and 4 units down. Because it is greater than, we're going to use a dotted line. Alright, if it was greater than or equal to, we would use a solid line. So we're going to do a dotted line to graph the quadratic. Alright, and then the last thing is, where are we going to shade? You could have done this possibly 2 ways. One is to test a point. And in most cases, 0, 0 is an easy point to test, so you plug it in. 0 is greater than 0 plus 3 squared minus 4. So 0 would be greater than 9 minus 4. And 0 is greater than 5. Well, is 0 greater than 5? No, that's false. So at that point, 0, 0, which is right here, if that's false, then all those points are false that are outside the parabola, so that means you can shade inside. The other thing, and I like to do it this way, and so this might be new for some of you, so you might want to listen just in case you haven't done it this way. I think it's a little bit easier and makes sense as well, is that if you look at the inequality, if it's greater than, and you're saying y is greater than, well, think of all your y values. Y moves up and down. So if it's greater than, then you are going to shade above all those y values. If y is less than, then you will shade below all those values. So in this case, y is greater than, so you can pick any y value on the graph and you want to shade above. So I'm just going to draw some arrows, pick some numbers or some points on the graph and draw arrows that go up. That's where you shade. So that means you would be shading inside the quadratic, inside the parabola. So either way works. You can test a point or you can use the shading to see whether you shade above or below that line. Alright, so let's do one more example. This example is an absolute value, once again using transformation. So we'll go through the transformation part, graph it, and then do the shading. So on this one, if you want to pause it and see if you can go through and do this on your own, but the x minus 3 inside, the 3 is happening with the x, so that's a shift left and right. So on this one, we're going to go to the right 3, so 3 units to the right. We also have that the 2 is a multiplier. It's 2 times the absolute value. So you're taking 2 times the function. And if you're taking 2 times the function, 2 times the y value, that means the y value is changing. So this is a vertical stretch of 2. So we've got a vertical stretch by a factor of 2. And then the negative, once again, is happening to the function as well. It's not with the x, it's with the entire function. So when you have a negative y value, okay, the y value is changing. So if the y value is changing, then it's reflecting over the x-axis. So we also have a reflection over the x-axis. All right, so those three things. So we have our parent function, which is 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2. And then these three things are going to happen. So we're going to take the vertex, which was at 0, 0, and we're going to shift it 3 units to the right. So now here's your new vertex. All right, it's going to get reflected over the x-axis. So instead of opening up, it's going to open down. But it's also going to happen by a stretch of 2. So instead of going, you know, like this, I'm going to erase this, but instead of doing this, all right, all those y values get multiplied by 2. So instead of being 1 over 1 down, it will now be 1 over, and with the stretch of 2, it'll be 2 down. Instead of 1 over again to the left and 1 down, it'll be 1 over and 2 down. And now, instead of having a slope of 1, we have a slope of 2 and negative 2. And that's what that vertical stretch does. And so now we're able to graph. That'll work, I guess. And it is solid. So we do have a solid line. Put some arrows on it. Oops. And then now where do we shade? Well, when I see y is greater than or equal to, I know to shade above all my y values. So if I pick any of these y values and draw arrows up, then you're going to shade everything above the absolute value. So your solutions are all the ordered pairs on the absolute value boundary line and anything above that. And you could test a point. You could just take a point, any point that you wanted that's in there. You know, you could obviously do 0, 0, that would be fine. But you can do any of these points. All right? And if you plug them into the inequality, they will produce true solutions. All right, so that is it really. Once again, just working on transformations again, and then also with the inequalities doing some shading. Also, in class, I will show you how to do this on the graphing calculator. It's kind of nice to see. Some of you guys don't realize that you can actually graph inequalities on your graphing calculator. So I will show you how to do that as well, just as a tool, something that you could use on ACT and things like that. So that is it. So you guys will have your worksheet in class on these notes. So thank you.